Hey, Mr. Dueck here. I'm going to record some short little tutorials for my Physics 12s. So this first one is if you're launched horizontally from a cliff. What do you do if you're launched horizontally from a cliff? What can I ask? So here's the question. A projectile is launched horizontally from a cliff. From how high? Well, first of all, I can either give you the horizontal distance and say find the height, or the vertical distance and say find the range. So I'm going to start out this time giving you the vertical distance and saying find the range. Find the range. The other thing that I would do is I would underline the word horizontally. Okay, so I have a 19.5 meter high cliff, and I have an initial velocity of 28 meters per second. I would do my usual T-table approach. I would break this up into its horizontal and vertical components. Right away, I would write AX is 0, AY negative 9.8. I would write VX is 28. I would write, and this is the most common mistake, Vy initial is 0. Students want to put that 28 there. No, that 28 is horizontal. What's the initial vertical velocity if you're launched horizontally from a cliff? For a split second, you haven't started following yet. Then they're either going to give me a dx or a dy. Remember, dx is another word for range. In this case, they gave me the vertical displacement, and I have to make it negative because we are ending up below from where we started from. Now that I've done that, I'm committed. In the vertical column, this is where I have 1, 2, 3 pieces of information. This is where I can now find time. I'm looking for an equation that has acceleration, velocity initial, distance, and time. It's this one. And conveniently, which really means this equation modifies into this, at squared over 2. That's a half at squared. And I'm trying to get the t by itself. I can do that. T is going to be 2 times d divided by the way, you could use a quadratic formula on this, but it's a waste of time if you can get the t by itself. Yes, this is a quadratic, but this is a nice quadratic. The time of flight is going to be the square root of 2 times negative 19.5 divided by negative 9.8. It's going to be 2, oh, gonna sneeze. Sorry, I'm back. Fighting a cold today, but still teaching. Negative 19.5 divided by negative 9.8, and I get 3.9795. You know what? I'm going to go 3.98. 3.98 seconds. Let me double check that. Is that right? Oh, I forgot to square root, Mr. Dueck. How about you square root? Good gosh, I am fighting a cold. You know what? I'm going to go 1.995 seconds. That seemed a little high to me. I'm going to go 1.995 seconds. And the nice thing is, I can transfer that over to here. The time of flight horizontally is also 1.995 seconds. Well, how does that help me? Well, now I can find the range, dx. The range is going to be oh, hey, that cancels because a horizontally is 0. Again, most common mistake. Kids put a negative 9.8 into a horizontal. Don't do that. The range is just Vxt. The range is going to be 28 times 1.995. It's going to be really close to 56. 55.9 meters. Now, in this question, I gave you the vertical height, and I said find the horizontal range. I could have given you this value. If I'd given you the horizontal range, I could ask you to find the vertical height. You would use this equation, and you would get the t by itself. T equals d over v. And then once you had time, you would bring it over here, and you could use it in this equation, d equals vit plus a half at squared, where vi is 0. In fact, you would use it in that equation, and you could find the vertical height. Either of those is fair game on the test, as far as I'm concerned. What else could I ask? Well, I could ask you to find the impact vertical velocity. Now, the reason I'll probably say final vertical velocity, and the mistake that drives me crazy is I have students say, oh, v final is 0. No, that's after it hits the ground. Yes, everything eventually comes to a stop when it hits the ground. What goes up must come down. I realize that. When I'm talking about the vertical velocity, the final vertical velocity, I mean the split second it hits the ground when it's still moving. And it's vertical. Did I say vertical? Let's relist my vertical data. I said AY was negative 9.8. I said VY initial was nothing. I said dy was negative 19.5. And I do have another value now. I know that time is 1.995 seconds. And they want me to find, well, there's two ways that I could do this. I could go v final equals v initial plus at, or I could go vf squared equals vi squared plus 2ad. Cool. Okay. The left one is easier, but I'm going to be using time that I calculated to find v final. What that does mean is if I got time wrong, I'm getting v final wrong. But you know what? We're in Physics 12. It's time we got over our fear of time. Shut up. Okay. It's time that we got comfortable finding answers and using that to find new answers. So I'm going to use the left-hand method. Vf equals 0 plus negative 9.8 times 1.995. I get the final vertical velocity is going to be negative 9.8 times 1.995. I get negative 19.6 meters per second. Or I could have gone, how do I get rid of a squared? Square root. And I could have said this is going to be the square root of 0 squared, which isn't going to make a difference, plus 2, negative 9.8, negative 19.5. I could have gone to my calculator and gone 2 times negative 9.8 times negative 19.5. This time I'll remember to square root. And of course, I get the same answer. Oh, wait a minute. Where's the negative? And again, that's the weakness with this equation, the vf squared equals vi squared plus 2a. It's very handy, but it often gives you it gives you a positive answer. It gives you a scalar answer, even if you're heading down. So this is where we have to say, wait a minute, I know it's heading down. So although my equation gave me 19.5, very close to the 19.6, but we rounded off a bit, I have to add the negative. And yeah, sometimes your third sig fig might be a tiny bit off because of the rounding off. What else could I ask? I could say, find the impact velocity, magnitude, and direction. Okay. What do I mean by the impact velocity? I mean when it hits the ground at an angle. Whomp. This is the impact velocity. So it hits the ground. When it comes and crashes into the ground, it's moving horizontally, and at the same time it's moving vertically. It's moving at an angle. Did I say angle? That's a job for components. Where Vx was, what was it, 28? Because that doesn't change. And Vy final, now I have just calculated it. If I hadn't calculated it, I'd have to do that right now. And I got a Vy final of 19.6. I dropped the negative here because the arrow is pointing down, which implies negative. How can I find the magnitude now? Well, this is going to be straight Pythagoras. This is going to be V impact squared equals 28 squared plus 19.6 squared. The impact velocity is going to have a magnitude of 28 squared plus 19.6 squared, square root, 34.2 meters per second. Direction, well, the angle that I want is this angle here. This angle. I'll call it theta. And this is opposite, this is adjacent, it's going to be tangent. It turns out tan theta is going to be opposite over adjacent. Don't forget brackets on your calculator. Mine puts them in automatically. And I get, oh, almost exactly 35 degrees. 35 degrees. If you said south of east, I'd take it, but we're looking at a side view, so we say this is below the horizontal. That's the impact velocity. 34.2 meters per second at a 35-degree angle below the horizontal. So I'm going to give you one more that you can try yourself. So I'll put the question up. Once you see the question, if you want to get a piece of paper out, copy it out onto the piece of paper, try it, then press play. So pause the video while you're copying it, try solving it, then press play. All right? So first of all, we'll give you the question. Let me pause the video and type it up. So here's the question. We have a horizontal projectile. It's launched horizontally from a 36-meter high cliff with an initial velocity of 52 meters per second. Part A says, find the range. Part B says, find the final impact velocity, include the magnitude and direction. So to do part B here, you're going to have to find the final vertical velocity, which I included as a separate question in my example. I'm combining them together in this one. So pause the video, copy this question out, and try it. So hopefully you've tried it. Now I'll walk through it quickly here. All right, we have, well, I would probably underline the word horizontal. That's going to be important. That's going to help a lot. And let's go with my traditional T-table approach. So I have horizontal, I have vertical. I know AX is 0. I know AY is negative 9.8. I know VX is 52. I know Vy initial is 0. I know dy is negative 36. I can find t. How will I find time? I'm not going to walk you through all the steps. I would end up going t equals the square root of 2d over a. I would end up with time being 2 times negative 36 divided by negative 9.8 square root. I would get a time of 2.711. 2.71, oh heck, 05 seconds. And I would transfer that to here. And now I could find the range. So part A, the range is going to be Vxt, no plus a half at squared because a is 0. It's going to be 52 times 2.7105. The range is going to be 52 times this, and I get 141 meters. What else can I ask? Oh, impact velocity. Now, impact velocity is a much tougher question. So B, impact velocity, which I know looks like that. And I know it's made up of Vx and Vy final. Vx was 52. Question told me that, and that's never going to change. Vy final, I'm going to have to find. How will I find Vy final? Well, I can use V final equals V initial plus AT as long as I use everything vertical. V initial 0, negative 9.8, 2.7105. Don't need to write the 0 plus. Negative 9.8 times 2.7105, and I get negative 26.563. I get V final equals negative 26.563. I'll carry extra sig figs because I don't want to round off because I'm using this to find an actual answer. I ditched the negative because the arrow pointing down means negative. Now I can find V final, V impact. V impact is going to be, well, Pythagoras. 52 squared plus 26.563 squared, square root, 58.4 meters per second. There's the magnitude. Direction. Here's my angle theta. Opposite, adjacent. Tan theta equals 26.563 all over 52. Shift tan, bracket, 26.563 all over 52. And I get 27 degrees below the horizontal. Okay. Hopefully you got that. If you need more practice, see me. But there you go.